Right. So last class, this is what we had discussed, how to integrate when vectors are involved. That means when I cap and j cap are involved. From velocity, we found out displacement and position. Then we moved on to motion in 2 dimensions under gravity. Like if an object is projected at a certain angle with the horizontal, how to find out what happens to that object, how to describe the motion of that object is what we discussed. So the basic idea here is when an object moves in 2 dimensions, you can split its motion into two separate or two independent one-dimensional motions, one along the x-axis and one along the y-axis. And how do you do that? You write its initial velocity in terms of, as the sum of its x component and y component. That is what we did here. The initial velocity was u at an angle theta with the x-axis with the horizontal. So we split it into two components. The x component is u cos theta, y component u sin theta. So the velocity can be written as u cos theta I cap plus u sin theta j cap, or simply ux I cap plus uy j cap, where ux is the x component, uy is the y component. So yeah, before you start describing the motion of this object or doing any calculations, you split its velocity into two components like this. Similarly, you express the acceleration also as components along the x-axis and y-axis. Now, acceleration due to gravity, we know it is always vertically downward, and downward direction is the negative y direction. So the acceleration will be written as minus g j cap. Okay, where g could be 10 or 9.8, they'll specify that in the question. Okay. But direction is in the downward direction, so negative y, so minus j cap, minus g j cap. That's what we did. So once we have the initial velocity and acceleration vectors, and we know acceleration is constant, we applied equations of kinematics. Okay. And using equations of kinematics, we derived an expression for h max. H max is uy square divided by 2g. And then we found out time of ascent, uy divided by g, where uy is the y component of velocity, because that component is what makes it rise up, okay, perpendicular to the ground. Then we saw that time of ascent will be equal to time of descent. Add both, you'll get the time of flight, 2uy by g or 2u sin theta by g. And as I said, this expression for time of flight is valid only when the initial level of the object is same as the final level. If the object is allowed to fall for a longer duration, or if the object is caught before it comes back to its starting level or initial level, then time of ascent need not be equal to time of descent. Okay, so it depends on the situation. Anyway, we'll solve problems. You'll understand how to find out time of flight or time of ascent, time of descent in any case. And the last thing I think we discussed was an expression for, we derived an expression for the horizontal range, like how far from the point of projection is the object going to hit the ground. Okay, and range is basically displacement in the x direction. So we used uxt plus half axt square. We got it as u square sine 2 theta by g, right? So yeah, if any of you have any questions in what we discussed in the last class, you can ask. Otherwise, we'll continue. Okay. Just a moment. I'll copy one diagram. Okay. So what we learned in the last class was if you know the initial velocity, that is the velocity with which the object is projected and the angle at which it is projected, we know how to calculate the h max, the maximum height that it will rise above the point of projection. And we know how to calculate the horizontal range. We know how to calculate time of ascent and time of descent. Fine. Can one of you tell me, like during this motion of the object, at which point will the object or the ball be moving the slowest? Those of you who attended the previous classes, at which point will the object be moving the slowest?
Sir, at H max.
Maybe at high point.
At the highest point. Okay. Answer, you tell me. what made you feel that it may be moving the slowest at the topmost point? What you said is correct only, but how did you conclude?
Because the angle is larger. The
What angle
speed
are
like
you talking?
no, because when it is going up, the gravitation is not acting.
Okay, you should not say it is not acting. It is acting in the opposite direction, so it slows it down. Okay. Uh, Pawan, on what basis did you say at the maximum height it will be moving the slowest?
Sir, velocity on y-axis will be zero.
Velocity?
On y-axis will be zero.
Okay, velocity in the y direction will be zero. Good. Okay, fine. Now see, we had discussed this before also. Velocity, initial velocity, you can see it is at an angle above the horizontal. Acceleration due to gravity, as we all know, is downwards, g. So if you take its components along the line of velocity and perpendicular to the line of velocity, g's component along the line of velocity, you can call it as the parallel component, is opposite to velocity during ascent. Okay. So as a result, what happens is it slows down. During ascent, the ball slows down. Okay. And then during descent, you consider a random instant on the right side, maybe somewhere here. Let's say the velocity is v, some random velocity, and gravity will be vertically downward, as always. Now you take the component of gravity along the line of velocity. You see that the component is in the same direction as velocity, not opposite to it. Initially, if you observe it, g component was, gravity component was opposite to velocity. Not just initially, anytime during ascent, the situation will be like that. And anytime during descent, the parallel component of gravity will be in the same direction as velocity, means it will make it speed up. So during descent, the object speeds up. So during ascent, it slows down. So it gets slower, reaches the minimum speed, and then starts speeding up during descent. So this way also you can tell that at h max, it will be moving the slowest. Okay. What Pawan said is also correct. That is a mathematical proof, you can say, because at h max, maximum height, the speed, if you see, generally the speed is written as root of x component square plus the y component square. Okay. Speed is magnitude of velocity. This is how we calculate its magnitude. At h max, the y component of velocity totally becomes zero. So the speed will only be the x component of velocity, that is u cos theta. The horizontal component will remain with it. No vertical component, and that is the least possible speed that it can have during flight. Okay. Let's solve one question quickly, and then we will discuss further details about 2D projectile motion. Assume the speed of projection here is some, okay, I'll write it on the right side. Let's say speed of projection is 25 meters per second, and the angle at which it is projected is 53 degrees. Okay. Now you all tell me, like, calculate this quickly. What is the maximum height it reaches? And what is the minimum speed during its flight? Okay. Solve both questions and type your answers in chat, all of you. Okay, I got only 2 answers so far. Okay, Vanilla, both your answers are correct. And I got Hmax, one answer for Hmax has 4 meters. Hmax is not 4 meters. Okay. Saket, tell me, how do you calculate Hmax?
Sir, u sin theta whole square by 2 grab 2
2g, yeah, correct. Answer, have you studied motion in a straight line?
Yes, sir.
Motion in a straight line under gravity, like when a ball is projected up, do you know time of ascent, Hmax and all?
No, but we
Not-
need to take minus g.
Yeah, acceleration should be taken as minus g. Good. Anyway, there is an equation. I mean, there's a formula for it that we derived. So how high the ball rises depends on this component of velocity, the y component. Now the velocity, the actual velocity here is 25 meters per second. And the angle is 53 degrees. Then its y component would be uy is equal to u sine 53 degrees or cos 37 degrees you can take. Okay, I prefer it that way. And that will become 20 meters per second. Okay. Then Hmax, the formula for Hmax is uy square divided by 2g. Okay, square of the velocity in the upward direction divided by 2g, which in this case becomes 20 square divided by 2g is another 20 because g is 10. So 2g 20, effectively the Hmax becomes 20 meters. Pawan, how did you get 40? What mistake did you make?
Sir, you square చేయడం మర్చిపోయాను.
If you don't square, you'll get 1. 20 by 20 is equal to 1. How did it become 40? Anyway, let it be. Then my next question was, what is the minimum speed during the flight? Okay, I got answer only from Vanilla. That's good. Vanilla, how did you find out the minimum speed?
Sir, the speed is minimum when y component is absent, like it's 0, that's why.
Okay, at Hmax, we know the speed is minimum. And we discussed this point before also. Everywhere during the flight, the x component remains constant. X component is u cos 53, that is 25 cos 53 degrees. That becomes 15 meters per second. Everywhere during the flight, it will have the same x component. Vanilla, can you also tell why the x component does not change during flight?
Sir, because the gravity is acting in horizontal direction,
Vertical direction. Okay.
vertical direction.
Gravity acts vertically downward. It has no effect in the horizontal direction. So there's no acceleration in the horizontal direction. That's why the x component of velocity never changes. The y component decreases during ascent. Keep this picture in mind, all of you. Okay, it will help you solve problems quickly. Initially, there was a large y component. The y component gradually decreases. And at Hmax, the y component is totally 0. You won't have a vertical velocity at all. Okay. And then during descent, the y component will appear in the downward direction. That's why it's coming down. Finally, it will be like this. Okay. So this is what happens during flight of the object. Okay. So at Hmax, the speed is minimum. And at Hmax, the speed is the x component of velocity itself. And we know the x component is 15 meters per second. So that itself will be the minimum speed during flight. Hope this is clear to all of you. If you have any questions, you can ask. Okay. Now see, the ball was projected with a speed of 25 meters per second at the ground. Okay, from the ground. At Hmax, its speed becomes 15 meters per second. So at the initial point, at the starting point, it has a speed of 25 meters per second. By the time it reaches here, its speed becomes 15 meters per second. Then it should have gradually changed, no, from 25 to 15. Okay, during the time of ascent, okay, during the time for which it ascends, the speed slowly changes from 25 to 15. So at some point, its speed must have been 20 meters per second, because it can't suddenly go from 25 to 15. No, it has to gradually decrease from 25 to 15. So at some level, at some height, its speed would be 20 meters per second. And see, we know its velocity at the ground level, we know its velocity at h max, but using some or the other equation, we should be able to tell what its velocity is at some other height. We know h max is 20 meters. Okay, then at 15 meters, you should be able to tell what speed it has. At 10 meters, you should be able to tell what speed it has. Okay, that is one thing. Next, the angle at which the ball was projected is 53 degrees with the horizontal. But you observe when the ball reaches maximum height, one of you quickly tell me, when the ball is at the maximum height, which way is it moving? In which direction is it moving? Someone unmuted, but the voice was not clear. Still not clear. Okay, anyone else? At maximum height, which way is the ball moving? Just see and tell.
Sir, horizontal.
Horizontal. Means what angle is it making with the x-axis at maximum height?
Sir, 0.
Degrees.
0 degrees. Okay. At maximum height, since the ball is moving horizontally, it makes 0 degrees with the x-axis. Okay. But initially, what angle was it making? 53 degrees it was making. At h max, it makes 0 degrees. Now the velocity vector, okay, let me copy the diagram once again. The velocity vector gradually rotates, right? Initially, it was at making an angle 53 degrees. Later, it makes a smaller angle, slightly smaller angle, an even smaller angle. And at h max, okay, finally, when the ball reaches h max, it becomes horizontal like this. So the angle made by the velocity vector would gradually change during flight. So you should be able to tell what angle it will make at a certain height. Okay. What angle it will make after a certain time. What angle it will make when its speed becomes 20, 10. Okay, speed of this ball never becomes 10. Minimum speed is 15, we found out. But you should be able to tell what angle it makes when its speed is 20, 18, something like that. Okay. So there are a lot of other things that we can find out in projectile motion. Okay. Not just H max, range, time of ascent, time of descent. And in today's class, that is what we are going to learn in detail, how to tell anything about a ball which is projected or about an object which is projected under gravity. That is what we are going to focus on in today's class. Okay. So we'll take it step by step. First, velocity at any height. We'll first learn how this can be calculated. Now, what are the things that we know? We know the initial velocity. Okay. In fact, we know the components also. We know the x component. We even know the y component. That is u cos theta I cap and u sin theta j cap. And we know the acceleration. Can one of you quickly tell me the acceleration in terms of I cap and j cap? Once the ball is projected. Yeah, Vanilla, go ahead.
Minus 10 j cap, sir.
Minus, okay, let's write it as minus g j cap. Once we start taking value, like if the initial velocity is given to you as a number, numerical value is known, then you can substitute 10 in place of g. Okay, for now, let's call it g itself. Okay, so we know the initial velocity, we know acceleration, and we know it is starting from the ground level. Like we know the initial level from which it is projected. Okay. So our aim now is to calculate the velocity at a certain height. Let's consider this position of the ball. When the ball reaches here, it will have some velocity in this direction. It will be moving this way. This is what we need to calculate, and the height will be given to you. At what height you are required to calculate the velocity, let's assume that is known. Our aim now is to calculate that velocity. So think about this, all of you. First, consider what all you know. Okay. Initial velocity is given, acceleration is given, this height is also given. Then consider what you have to calculate, the velocity at that height. Tell me how this can be done. We also know that acceleration due to gravity is a constant acceleration. So you can apply equations of kinematics. So keep all these in mind and tell me some way to calculate that velocity. Some method to calculate that velocity.
Sir, v square minus u square is equal to s.
You want to use v square minus u square is equal to 2as. Let's see. Listen, all of you. Let's consider that suggestion. Pawan, what is our aim? What do we want to calculate?
Sir, final velocity.
V. Okay, this is what we need to calculate. Okay, we know u. We know a. What about s? First tell me, in v square minus u square is 2as. What does s mean?
Sir, displacement.
Displacement, correct. Do we know the displacement of the ball?
Sir, we should find out the height.
We should.
Find out the height.
Which height? Height h is given to you. Answer, there is some noise from your side. Pawan, the height h is given to us. What displacement will you take to calculate that velocity? Okay, others, if you have any ideas, you can share. Okay, think about this, all of you. We already know something about that velocity. Can you tell what we already know about that velocity? Let me give you an even better hint. We already know something about velocity at every point. What do we know?
Its x component is constant, sir.
The x component, correct. So we already know the x component here, Vx. It is same as the initial x component because the x component doesn't change due to the absence of acceleration in the x direction. Okay, so whatever is the initial x component, the final x component also will be the same. Okay. Then to get the complete velocity, what is the other thing that we need to find out? What else do we have to find out? We already know the x component. Our aim is to tell the complete velocity. So what else do we need to know or find out?
Displacement.
With displacement, what will you find out?
Its y component, sir.
The other thing we need to find out is the y component of its velocity. That's all. Once you know both components, you know the vector completely. So this is what you should try to find out. The velocity is y component. And y component does not remain constant, it keeps changing. Initially, the y component will be large. But due to gravity, as the ball ascends, the y component decreases. And we know the initial y component, uy is known to us. Okay. So the only thing we have to find out to get the complete velocity, the only thing we are left with to find out is the y component of velocity. Can one of you suggest a method to derive the y component of velocity?
We should find out the y component of the displacement, sir.
Okay, good. So you are saying you need the y component of displacement, and which equation you will use to get the y component of velocity from displacement? Like suppose you know the y component of displacement, how will you find out the y component of velocity from it?
So V is equals to U plus AT.
Answer what you said is reasonable only. V is equal to u plus at. But if you want to apply V is equal to u plus at, you need to know the initial velocity, which is given in this case. You need to know the acceleration, which is known in this case. But we don't know the time it takes to get there. Okay. What you are given is the height. So you should try to make use of the height. Vanilla, you are almost there. You said we need displacement in y direction. What will you do with it is the question. How will you use it?
Sir, if we find out the y component, we can use it in the equation also.
Which equation? That is what I'm asking.
V square
V
minus
square minus u square is to s. Okay, fine. Don't you know the displacement in the y direction up to that height? The height is given to you.
Yes, sir.
Okay. Listen, all of you. This is what you'll have to make use of. The height itself is its displacement in the y direction. See, the total displacement of the ball will be from the point of projection to this point. That's the total displacement. That is not known to us. Okay. But that displacement's y component, that is nothing but the vertical displacement, is known to us. That's the height at which we have to find out the velocity, right? So indirectly, the displacement in y direction is known. We know acceleration in y direction. We know initial velocity in y direction. Using that, we can find out the y component of velocity. And once you get the y component of velocity, you know the x component already. Now you got the y component. You can tell the complete velocity. Okay. Did you all understand the idea? One important thing to keep in mind when solving problems about 2D motion under gravity is that you always know the x component. The x component always remains same, so you don't have to bother much about it. If it is known at one point, it is known at all points. The only other thing you need to find out is the y component. Okay. Once you know x component and y component, you can write complete velocity as x component I cap plus the y component j cap. You can even tell the speed at that height. How do you tell the speed? Magnitude of velocity. That is square root of vx square plus vy square. You can tell the speed at a certain height. Next, if you know the x component and y component of a vector, let this be the x component, let this be the y component, you can visualize the vector and even tell what angle it makes with the horizontal. Okay, I was talking about this a little while ago. Initial angle is 53 degrees, but at h max the angle is 0 degrees. Then in between it will make all other angles like 52 degrees, 50 degrees, 45 degrees, 30 degrees, 37 degrees, all the angles will be touched. Okay, so you can even tell what angle the velocity will be making at a certain height, means in which direction the ball will be moving at a certain height also you can tell. Okay, so simple idea, you can split 2D motion into two independent one-dimensional motions. Once you do that, you can find out everything about the object. Okay, hope the idea is clear to all of you. Let us solve one question based on this. Any questions? Like any doubts? Okay. If you have, you can ask at any time, not an issue. So let us take this case itself. Initial velocity of 25 meters per second at an angle of projection 53 degrees above the horizontal. We already calculated h max in this case. We know the h max will be uy square by 2g. We got it as 20 meters, right? Now my question is, calculate its velocity. Okay, and see here I have given you the diagram, but in exams, the final exams that you are going to take, or whatever it is, even the practice exams that you take, they will most probably not give you the diagram. Okay, they'll just tell you how they'll just describe in words how the object is projected, what you have to calculate. But if you imagine the situation, no, if you form a picture like this in your mind, solving physics questions becomes very easy. I told you this many times. So, okay. So maximum height is 20 meters. Then at some time, it will be at a height of, let's take 15 meters from the ground. Okay. So the question is, when the ball is at a height of 15 meters above ground, find out all those things that I said you can find out. Calculate its velocity, then its speed, and then the angle which it makes with the horizontal. Horizontal or ground. Okay. You can even calculate time it takes to get there. Time to reach that height. Okay. Do this, all of you. I'll give you 3 to 4 minutes. Remember how to start solving the question. Get the x component and y component of initial velocity first. Get the x component and y component of acceleration. Then use equations of kinematics carefully. Okay. Start solving.
Sir, should we take G as minus 10, sir?
See, g is the magnitude of acceleration due to gravity. G will always be taken as plus 10 only. Okay. But acceleration, we know acceleration in this case is downwards. Its magnitude is g, but direction is minus j cap. So you will take acceleration as minus g j cap. So minus 10 j cap is the acceleration. Manala, is it clear?
Yes, sir.
Huh. Any answers? At least for some of the questions.
So velocity is root 325 J caps.
See, so you are saying velocity is only in the y direction. You said
No,
root,
sir.
but you said answer root 325 j cap.
Plus 15 I caps. Sir.
In the y direction, I don't think it'll have that much velocity. Root 325. No, that much is not possible. Check your calculation once. Yusuf, can you unmute? We'll discuss. No response. Okay, Saket.
Sir,
Have you calculated anything?
no, sir.
Okay. What do we know about the velocity? Or, okay, wait, even before you answer that, tell me the components of initial velocity, x component and y component.
25 I cap.
No. 25 is the complete velocity. How much is its x component?
Oh, sir, I need to calculate.
Okay, do it. There is some background noise also. Let it be. Pawan, can you unmute?
Yes, sir.
Tell me the x and y components of initial velocity first.
Sir, 15 I cap and 25 20 J cap.
It will be 15 I cap and 20 J cap. See, it's the same question that we took before. Okay, this one, the beginning of today's class. I mean, we are using the same values. Anyway, this will be 15 I cap, that's the x component, and its y component will be 20 J cap. Vanilla, did you take the same components or any different components you considered?
Same components, sir.
Okay, let's see. Answer, you tell me. What do we know about the velocity at this height?
Sir, it would be increased.
Why will it increase when object is going up? Okay, anyway, I won't trouble you much. You are new. Pawan, you only tell me, what do we know about the velocity at that height?
Sir, it will be reduced.
That's okay. Anything else? Any numerical values that we know about it?
Sir, velocity and x-axis is 15.
We know the x component, correct? That is 15. What do you have to find out about it?
Sir, velocity and y-axis.
It's the y component of the velocity that you need to find out. Then you can answer, I think, all 4 questions. Okay, they're all based on this y component itself. Of course, the x component also, but that is known to us. So, Pawan, tell me, how can we calculate the y component of the velocity there? We discussed just before I gave this question. We know the height. Making use of the height, how to calculate the y component there? Okay, anybody else? Give me an idea to calculate the y component there.
V square minus U square equal to S. Sir.
So Vy square minus Uy square is 2 Ay Sy. That's all. So we don't know the y component. We'll keep it as it is. We know the initial y component. 20 square it is equal to 2. Acceleration in y direction is minus 10. And displacement in y direction is 15 meters. Okay, it raised by 15 meters, no? That is where you were asked to find out the velocity. That's all. So you get Vy square 20 square you send that side, it becomes 400 minus 2 into 10 is 20, 20 into 15 is 300. That becomes 100. Vanilla, how did you get 325?
Sir, I did some calculations.
Okay, no problem. So hope this is clear to all of you. We are getting Vy square as 100. If Vy square is 100, can one of you tell me how much Vy is?
10, sir.
Is 10 the only possibility? Square of what number or numbers is 100?
Plus or minus 10, sir.
Good. It could be plus 10 or minus 10. Listen, all of you. So we have two possible values of Vy at that height, plus 10 and minus 10. And both are correct answers to this question. Okay, so based on what we derived there, I'm going to write Vy is plus 10 or minus 10 meters per second. I'm not writing the unit. But tell me, what does Vy being plus 10 suggest and what does Vy being minus 10 suggest? Anyone? What does the positive value of Vy suggest and what does the negative value suggest? That's the question.
Sir, positive value పైకి ఫోర్స్ వెళ్తున్నట్టు నెగిటివ్ డౌన్వర్డ్స్.
Okay, positive velocity indicates positive direction, negative velocity indicates negative direction. Now, how come we got two answers for that height 15 meters? Observe the diagram. When the object is at a height 15 meters, there are two possible positions. Once during ascent, it will be at that height, and once during descent also, it will be at that height. Okay, not just during ascent, no, during descent also, there will be one instant when the ball is at a height of 15 meters. So at that other instant, during descent, what will happen? The x component, as we know, remains the same. That is always 15 meters per second only. The y component there will be minus 10. So here it is plus 10 meters per second upwards. There it is minus 10 meters per second, which means downwards. Okay, so for a particular height, you will have two velocities of the ball, of the object, except at h max. H max, it will touch only once. So at that height, it will have only one velocity, and that velocity is unique. Okay. But any other level you take, the ball will be at that level two times, once during ascent and once during descent. Not just this ball, generally projectiles. Okay. If you allow sufficient time of flight, it will be at the same level twice, once during ascent and once during descent. So for questions based on height, you may get two answers. So you need to understand that one of those answers corresponds to that height during ascent and the other answer corresponds to that same height during descent. Okay, fine. Now, Pawan, you tell me, during ascent, we know it's x component and y component now. Tell me the velocity, complete velocity.
Sir, 15 I cap plus 10 J cap.
15 I cap plus 10 J cap. Correct. That's all. And it's also possible that its velocity is 15 I cap minus 10 J cap, because during descent also it will be at that height once. So both are correct answers. Okay, we found the velocity. The next thing we need to find out is the speed. One of you tell me how to calculate speed from velocity generally. How are speed and velocity related?
Sir, magnitude of velocity.
Correct. Speed at any given instant is the magnitude of velocity at that instant. Fine. Vanilla, tell me how to calculate the magnitude of this vector.
Root of 15 square plus 10 square, sir.
Okay, square root of x component plus square of y component becomes square root of 325. 225 plus 100. 325 meters per second. You won't assign a direction to speed. Speed by definition only has magnitude. Okay, so that is how fast it is moving at that height. You won't include a direction. If you include direction, it becomes velocity. Okay, which we have already done. Okay, we got velocity at that height, we got speed at that height. During descent also it will have the same speed, because if you take root of 15 square plus minus 10 whole square, that will also be root 325 itself. Okay, so it doesn't matter whether it is ascent or descent. At a particular level, it will have the same speed during ascent and descent. Okay, and this is an interesting observation. Using this observation, you can tell its speed just before it reaches the ground, because at this level, at the ground level, we know its initial velocity, initial speed, sorry, 25. Then the final speed just before hitting the ground also should be 25 itself. Okay, we can tell that. Anyway, we'll prove it mathematically. Okay, what's the next thing we are asked to calculate? Angle made with the ground. Okay, observe this carefully. Initially, the angle made by the velocity with the ground was 53 degrees. As it rises up, the velocity vector tilts to the right side. Okay, so the angle it makes at this level, at a level of 15 meters, let's call that angle as alpha. Alpha will be less than 53 degrees. We should find out how much that angle is. Okay. Yusuf, can you, is your mic working? Can you unmute? No response. Let it be. Pawan, tell me. Okay, Yusuf is saying mic
Yes,
is
sir.
not working. Okay, no problem. Pawan, you tell me, how do we generally find out the angle made by a vector with the x-axis?
Sir, by
What is,
finding tan theta.
and to calculate tan of that angle, what all do we need to know?
Sir, opposite and adjacent.
So we need to know the components. When it's about a vector, we need to know the components. Correct. So if you want to find out what angle a vector makes with the x-axis or with the y-axis, you need to know its components, which we know in this case. At a height of 15 meters, this was the situation. The x component we know is 15 meters per second. That always remains 15 meters per second. Okay, that's the x component and we know it. Just a moment, let me adjust. And we found out the y component to be 10 meters per second. So visualize the y component. 10 meters per second, so it should be shorter, somewhat like this. And the complete velocity vector is from here to here. 15 I cap plus 10 j cap. Now what you are asked to find out is the angle it makes with the ground at that instant. This angle alpha is what we want. And I told you this idea before also. The two components of the vector and the vector itself. Okay. This is the velocity vector. This is its x component. And this side is its y component. The two components of the vector and the vector itself always form a right angle triangle. Okay, so you can use trigonometry to find out alpha. So tan alpha, the opposite side is 10 units long. The adjacent side is 15 units long. So this becomes 2 divided by 3. Therefore, you can express the angle alpha as tan inverse of 2 by 3 with the x-axis or with the ground. In fact, this situation is during ascent, right? During ascent, the vector will be pointed upwards. So you can say tan inverse 2 by 3 above the ground. Okay, sometimes you'll find options like this also in the objective exams that you're going to take. Now we know at 15 meters, at a height of 15 meters, it will have another possible velocity, that is during descent. During descent, when it is at the same level, its velocity is like this. The x component is 15 itself. The y component is minus 10 for descent. And the overall velocity will be pointed this way. Okay. This is 15 and this is minus 10. 10 downwards. Okay. Magnitude is 10, but it's in the downward direction. Now also we can tell what angle it makes with the ground. Let's call this angle as beta. Tan beta. The opposite side is 10 units long. The adjacent side is 15. So again, 2 by 3 itself you will get. So beta is tan inverse 2 by 3. But this time that angle is made below the ground. Okay. So visualize it, imagine it like this, all of you. At the same level, when the object is at the same level during ascent and during descent, there is a symmetry. During ascent, the angle made is alpha above the horizontal, as you can see in this diagram. We found the angle as tan inverse 2 by 3, let it be. If it makes some angle above the horizontal, then during descent at the same level, it is going to make the same angle below the horizontal. Okay, so whatever angle it makes during ascent at that height, same angle it will make during descent at the same height. One more thing we already proved is the speed. We found speed to be root 325 meters per second, right? During ascent. During descent also at the same level, it is root 325 meters per second. So there are some common things that happen during ascent and during descent. Fine. Now the last part of the question, time taken to reach that height. Can any of you tell me a method to calculate the time it takes to get there to a height of 15 meters? Quick.
Sir, S is equal to UT plus half t square.
Okay. Pawan is saying we'll use S is equal to UT plus half AT square. Reasonable. Our aim now is to calculate the time it takes to get there. From this equation, if you want to calculate time, you need to know displacement, initial velocity, and acceleration. Tell me the values, Pawan. How much displacement, initial velocity, and acceleration will you consider? I'll show you the diagram if you want. We need S, U, and A. What will you take? What values will you take?
Sir, S is equal to 15.
Okay, you want to use the displacement 15. The displacement 15 is in which direction?
Y-axis.
Y. Okay, so you should say the equation is Sy, displacement in Y direction, is initial velocity in Y direction into time plus half acceleration in Y direction into time squared. Okay, so this way if you write, it will be better. Okay, displacement in Y direction is 15. Initial velocity in Y direction, we knew it was 20 t plus half. Acceleration in Y direction is minus 10 t square. Okay, we can even simplify this equation. 2 and 10 becomes 5. Cancel 5 throughout. You get 3 is equal to 4t minus t square, or t square minus 4t plus 3 is equal to 0. What kind of equation is this?
Sir, quadratic with respect to t.
It's a quadratic equation in terms of t. Correct. Pawan, continue. How many roots does a quadratic equation have?
Sir, 2 roots.
2 roots. Good. That means there will be 2 possible values of t that you get. For one height, why are we getting 2 different times? Our aim was to find out the time when it is at a height of 15 meters. Can any of you explain why we are getting 2 different times for the same height?
Sir, one time is for ascent and one time is for descent.
Correct. We know the object will be at that height twice. Once during ascent and once during descent. So if you solve this quadratic equation that we got, you can tell both the times together. Okay, the time during ascent when it will be at that height, and the time during descent when it will be at that height, both you can tell. Okay, there are some interesting things we can find out from here. So can any of you quickly calculate the roots of this quadratic equation, please? You may use factorization, or you can use that formula for roots of quadratic equation, minus b plus or minus. Do whichever you are comfortable with. Tell me the roots.
3, 1.
Okay, we'll always tell the smaller root first. So 1, 3. Fine, listen all of you. Those of you who are still trying to find out the roots, you can do it later. Okay, we get two possible times, 1 and 3. 1 is the shorter one. I mean, t is equal to 1 second is what we come across first, and t equal to 3 seconds happens later. Okay, therefore we can say that the object is at this height first time. Okay, let me erase all this just to make things clear. The object is at this height (15 meters) first time at t is equal to 1 second, and the second time at t is equal to 3 seconds. Okay, that is what the equation tells us. That is why we got two different roots. And see, s is equal to ut plus half at square is not the only way to calculate time taken to reach somewhere. Now we already found out the velocity at that level, right? So you could have used v is equal to u plus at also. Okay, let us do it that way. I'll do it quickly. V is equal to u plus at, right? I'll use the y components. Now at that height, one possible y component is plus 10, is equal to initial y component was 20, acceleration due to gravity minus 10 into t. That's all. Send 20 this side, you will get minus 10 is equal to minus 10t. That means t is equal to 1 second. Correct? The y component is plus 10 at t equal to 1 second. Y component being plus 10 indicates ascent. Okay. So during ascent, it will be at that height at a time of 1 second. That is what the equation gives us. Now we know it will be at that height during descent also. If you want to find out that time, use the y component of velocity during descent. Minus 10 is equal to u, okay, uy plus ay into t. So send 20 this side now, you'll get minus 30 is equal to minus 10 into t. That makes t 3 seconds. That gives you t as 3 seconds. So what happens at 3 seconds? The y component of velocity becomes minus 10. And when is the y component of velocity minus 10? When it is at that same level during descent. So that happens at 3 seconds. And so these are the different ways in which you can find out something about this projectile, okay, object which is projected. So remember, there are some things that we used while solving these questions. First thing was that we knew the x component. That is a very, very helpful thing. If you know the x component, all you are left to find out is the y component. Once you know both of them, you can tell almost everything about this object. So you should now try to find out, like, you know the x component. So what you need to find out is the y component. So write equations along the y-axis. You can make use of this displacement along the y-axis. Okay, and then find out velocity in the y direction. Then you can tell speed, angle, time, all those things. Okay. So I'll give you another question like this. Try to solve it on your own now. This time I won't give you speed and angle. I'll give you the components directly. Let's say initial velocity is 10 I cap plus 30 j cap meters per second. Okay, that's the initial velocity given to you as a vector. Okay. Can one of you quickly tell me how high this ball is going to rise? Because you know the x component and y component. I think you should be able to tell. What is the maximum height this ball will rise to? How is h max calculated?
Sir, 45 meters.
Tell the formula. How is h max calculated?
Sir, uy square by 2g.
Correct. So you get h max is equal to uy square, the square of y component of initial velocity, by 2g. 900 by 20 becomes 45 meters. Okay, cool. I want you all to find out, like when the ball is at a height of 25 meters above the ground. Same things. Calculated speed. Okay, calculate velocity. Once you know velocity vector, calculating speed is not a big deal. You can do it. Then calculate the angle it makes with the horizontal. And time it takes to get there is easy only. Okay, do these two parts. So when it is at a height of 25 meters above the ground, calculate velocity and the angle it makes with the ground. Type your answers in chat. I'll give you 3 minutes to solve this. Make it fast. I only got one answer, that too only for velocity. What happened? Why are you all so slow today? Okay. Pawan has given answer for velocity, speed, angle also. Fine. The way you typed it is wrong, the angle, but okay, I understand what you did. Vanilla, you could not find out the angle. Use components, tell the angle directly. The other day you were telling the formula, angle made with x-axis tan inverse y component by x component. Use it directly. Okay, let us discuss. Answer, could you solve?
No, sir.
Okay, no problem. Fine. So yeah, this time the x component is given to you as 10 I cap. At this level also it will be 10 I cap itself. The initial y component is 30 j cap. But when it rises to a certain height, the y component will decrease. It won't be 30. That's the first thing we need to calculate. And for that, we will make use of this height. This is displacement in the y direction. So if you want to calculate the y component of velocity, vy square minus uy square is 2. Acceleration in y direction is minus 10. Displacement in y direction is 25. So you get vy square is equal to 30 square is 900 minus 2 into 10 is 20 into 25 is 500. Becomes 400. Square of what number is 400? Plus or minus 20. So vy could be plus 20. It could even be minus 20. And minus 20 corresponds to descent. That's all. So if you want the velocity as a whole, it will be 10 I cap plus 20 j cap or 10 I cap minus 20 j cap. Any one of these. One is for ascent, the other is for descent. And then the angle it makes with the x-axis alpha, just use the components. X component is 10, y component is 20. The velocity will be directed this way. And if you want to know what angle it makes, simple trigonometry, tan alpha is opposite by adjacent becomes 2. So alpha is tan inverse of 2. And just a moment, I'll look up this angle on Google, tan inverse of 2. Because the initial, okay, we don't know the initial angle also, never mind. So at that height, the angle at which the ball will be moving is tan inverse of 2. So like this, you can tell the angle at any height. Okay. All you need to know are the y component and the x component. X component is known. All you need to do is calculate the y component carefully. Any questions, anyone? Any doubts in this? Angle is tan inverse of 2 above or below the x-axis. Ascent, for ascent it is above the x-axis, for descent it is below the x-axis, same angle. Okay. Calculate range in this case. Range is basically displacement in the x direction. We had discussed this in the last class. If you want, you can use equations of kinematics. Otherwise, if you remember the formula for range, you can use the formula for range. Calculate the range, all of you. How far is it going to strike the ground? Okay, Vanilla, your answer is correct. How did you calculate?
So 2 into x component of u into y component of u by g.
Okay, fine. So listen, all of you, range is basically displacement itself, but in the x direction, in the horizontal direction, right? You can use ux into t plus half ax into t square. In case you don't remember the formula, you can solve from basics like this. Now, initial velocity in x direction was 10. Time, we'll think about it. Acceleration in x direction is 0, t square. So this term can be ignored. So the range effectively is 10 multiplied with the time it takes to get there. And the time it takes to get there is the time of flight. Okay, and we know time of flight is 2 times of uy divided by g. That's all. So, okay, let's keep this as ux itself. So this becomes ux into time of flight is 2 uy by g. So the range formula becomes 2 ux uy divided by g. We had discussed this in the last class. So 2 times ux is 10, uy is 30, g is 10. 2 into 30 becomes 60 meters. That's the range. See, based on the speed with which you are answering the questions, I can tell you didn't practice much. Okay. But you have to be very comfortable with these because, see, some of you are targeting NEET, some of you are targeting JEE. Especially the ones targeting JEE, you will most likely not be asked questions like this directly. Fine. They will, I mean, especially JEE advanced, it's always going to be multi-conceptual. What they will tell, like some person kicks the ball with a particular speed, it takes off. Okay, that initial velocity will be given to you, but they won't ask you direct questions about the ball like this. They'll give you something else, like maybe like another player comes in and the ball strikes the head of that other player. Okay, it was kicked from the foot of the first player, but strikes the head of the second player. They'll give you the height of the second player. They'll ask you with what velocity does it hit the second player? What is the relative velocity? At what angle does it appear to hit? So you should be very comfortable in quickly calculating these things that we discussed in today's class. Okay. Applying equations of kinematics in 2 dimensions. That's the main thing that you need to focus on. Okay. So I'll send you one worksheet tomorrow. It will completely have questions based on projectile motion in 2 dimensions itself, but you have to put some effort and solve those questions. Okay. As you all know, that is why I take classes on alternate days. So tomorrow during this class time, sit and solve that worksheet. By then you will have the worksheet in your hand. Okay. Right. So let's quickly go through what we discussed in today's class. We basically discussed how the speed changes during flight. As it ascends, the speed decreases. As it descends, the speed increases. So the ball or the object will be moving the slowest at the maximum height. And that speed that it has at maximum height is the x component. We all know that. Little bit of visualization, some calculations we did. And then basically what we discussed today is how to tell anything about the object at a particular height when it is at a particular height. Anything means what all did we find out? We found out its velocity, speed, angle it makes, time it takes to get there. Right? So next class, what we will do is we'll discuss, we'll find out all these things in terms of time. Like we know the time of flight, no? Like from initial velocity, we can tell the time of flight. So what we are going to do is maybe at 1/3 of the time of flight or some time before the time of flight, we'll find out all these things. What its velocity will be, at what angle it will be moving, how fast it will be moving, at what height it will be, those things. Okay, you can do it. It's not a big deal. In worksheet also, I'll include some questions like that. So tomorrow for 1.5 hours, you'll have to practice questions based on this. Okay, thank you all. We'll close the session here. If you have any questions, you can ask. Answer, you stay. The others, if you don't have any questions, you can leave.
Thank you, sir.
Hello, Joseph.
Yusuf, tell me.
Sir, I had a doubt with the tan inverse thing, sir.
Okay,
So what is tan inverse, sir? I thought when you say tan inverse, we get the reciprocal of whatever the value is, right?
No. Here inverse doesn't mean the reciprocal. Okay, let's take an example. What is sine of 30 degrees?
So I don't know.
Okay, 1 by 2. Okay. I mean, in ICSE, you didn't have any trigonometry at all in
So I
10th
had,
class?
but I haven't by heart.
Okay, fine, no problem. Sine 30 degrees is 1 by 2, that is 0.5, okay? So we can write 30 degrees as sine inverse of 0.5. Okay, because sine here, see, sine 30 degrees is not like sin multiplied with 30 degrees, right? It's not like a into b. If a into b is equal to c, you could have written b is equal to c divided by a. Okay, there we write it as c into a to the power of minus 1. That is with multiples. But here sine is not a multiple, sine is a function. Okay, there's a way to calculate sine, right? So sine, that function of 30 degrees is 0.5. Now, when you want to send the function to that side, you read it as inverse of the function. It's not reciprocal.
Okay, sir. Okay, sir.
That is what it means.
Yes, sir.
Okay.
Thank you, sir.
Right. So answer, like, how much could you understand in today's class? Are you there? If you are there, please unmute. Okay, no problem. I'll call you and we'll talk. Not an issue.